Hello students, welcome you all in Sudhir Jaiswal Edu Maths. Today we are going to learn sequence and series. Okay, so here we have a sequence. So sequence is actually a function whose domain is set of natural number. So it is a function whose domain, like for example 2, 4, 6, 8. Okay, so I said that it is a function. So here I took an example. Here you have 2, 4, 6, 8. They are a sequence. They are, so according to the definition, they are the function whose domain are set of real numbers. So here you see that you can write it the function this function as f of x equal to 2 times x, where x is a set of near natural number. So if you want to find the first term, you will definitely get 2 into 1, 2, 2 into 2, 4, second term 2 into 3, 6, third term. So there is also different definition, a set of numbers arranged in definite order, okay, according to the same sum rule. So the set of numbers, okay, arranged in definite order, according to some rule, okay, definite order according to some rule. With some rule you can say that order with some rule. So what are the rules? So we are now going to learn all these. So this is a sequence. Oh, okay. What is series? Series is a sum of sequence. Like if you write this a1 plus a2 plus a3 plus up to an, okay, these are the sum of sequences, okay. So what do we call it? It is finite, okay, finite one. And when we talk about a1 plus a2 in finite series, not it is finite series, n is defined here, okay. But when you talk about a1 plus a2 plus a3 plus up to, okay, so it is called infinite series. So what about the definition? That it is an expression. So here we can say that a1 comma a2 comma a3 up to an is a sequence, okay, sequence. So this expression is called, this is an algebraic expression. So this algebraic expression is called, okay, series, okay. So this one is finite series because n is defined. You can say a1 plus a2 plus a3 up to a10, yeah. And this is infinite because here that means a1 plus a2 plus a3 we don't have, this is endless, okay, here and so on. So now we are moving to the progression, okay. We have learned what is sequence. Sequence is a1 comma a2 comma a3 comma an, which is which have some order, okay, which has some rule, okay. And sequence is a1 plus series is a1 plus a2 plus a3 plus up to an, okay. They are the expression of this sequence, okay. You have studied it. Now we are moving to the progression. So the progression, if the term of sequence written under a specific condition, so we call it progression. If the terms are written in the specific condition, the terms are a1, a2, a3, a4, we call it terms. First term, second term, third term, fourth term. So if they are written in specific condition, then we call it progression. So first we will talk about arithmetic progression, okay. Arithmetic progression. So in this, what do you do? Like so this is a sequence, all right, and it has some order, or you can say that if it has some specific condition, then we call it progression. So what about arithmetic progression? In arithmetic progression, you find what the common difference, okay, always same, the term with preceding term, the difference between the term with preceding terms. How? What is d This is called common difference here. So the term A2 with the preceding term, difference between the term with the preceding term, okay, D equal to A3, the term with the preceding term, difference between the term with the preceding term. So A3 minus A2 is equal to A4 minus here A3, okay. So common difference is called D, and D is always same in the case of arithmetic progression, okay. So and so on if it has n terms, okay. So what will be the previous preceding term of an minus 1 here. So you can find the difference, what, an equal to an minus 1. So this is called what, arithmetic progression. So here we can write it again like this, how A1 can be written A plus D, third term A plus 2D, fourth term A plus 3D, fifth term A plus 5D, okay. This is the representation. And nth term A plus n minus 1 into D. This is also the representation of the arithmetic progression. So what next? Keep all these things in mind. What next? We have to learn the formula, okay. Nth term, what do you call it, Tn is the nth term, is A plus n minus, here we have nth term A plus n minus 1 into D. So can we say this is the last term? Yeah, we can say this time. So it can be also a last term, L equal to A plus n minus 1 into D, like this. Alright, yes. So if you want to find the nth term from the starting, what would it be? From the starting, from the beginning, the nth term would be what, A plus n minus 1 into D. So you can write it from beginning, okay, from beginning, okay, and nth term from the end. So if you want to find nth term from the end, okay, nth term from the end, that means you are not calculating from the beginning, you are calculating the nth term from the starting, okay. So how would you find it? Suppose this is T n dash, okay, and what do you need to do? This is L minus, I think, A minus L minus 1 into D, A minus L minus 1 into D. This is the formula, okay, sorry, L minus A minus 1 into D is this, sorry, L minus n minus 1 into D. You have to learn this. So this is the nth term from the last. So, and here L is the last term, n is the number of term, D is the common difference, A is the first term here, okay, and D is the common difference. These are the common differences and all. So now we are moving to where? So how many terms are there in AP? How many terms? Okay, question is how many terms are there in AP, like 20, 25, 30 up to 100. How many terms are there? How would you find? So this is nth term, what? You can say Tn equal to A plus n minus 1 into D, okay. This is nth term, yeah, the last term you can say here. So it can be a last term also, okay. So what is this? This is 100. What is A? A is 20. What is n? You need to find it. What is D? D, you find the term difference between the term with the previous, okay, with the previous term. So 25 minus 20, it is 5. 30 minus 25, it is 5. So you have to make sure that your sequence is in what, what in arithmetic progression. So here we have the common difference same all the time. Okay, that's why you can say that this sequence is in arithmetic progression, and here you can apply the rule, the property, the formula, and when you solve it, what is d here? You got it, 5. 25 minus 5, yeah. So 100 minus 20 equal to n minus 1 into 5. So 100 minus 20, it would be 80. All right, 80 upon 5. So here you would get what? 5 1 is 5, 5 6 is 30, n minus 1. So n would be here 17. All right. So if you want to find the sum of all these observations, that means sum of all first and n terms, or you can say that sum of all 17 terms here, how would you find? The formula is Sn equal to n by 2 2a plus Sn equal to n by 2 2a plus n minus 1 into d. What is a? The first term. What is n? Number of terms. What is d? Common difference. So here, so we have to find, that means what is S17? It is actually the sum of first 17 terms. What do you call it? The sum of first 17 terms. So find out what is n. We have 17 here. 17 upon 2 was 2a. What is a? 20 plus n minus 1. You can either use one more formula here. I have the easiest one. Sn equal to n by 2. You can also write, if you have a plus l, okay, a plus, what do you call, tn, or a plus l, the last term, what do you call? Or you can write Sn equal to n by 2 a plus l. Okay, l is the last term. Here you have 100. So what you can, 17 upon 2, you need to find S17, first sum of first 17 terms, 17 by 2. What is a? Is 20. What is l? 100. Definitely you will get the answer, 17 upon 2, 120. When you solve this, you will get answer 6 7 42, 2. So 120 is the answer. All right. Let's do the next question. Sum of all natural numbers lying between 100 and 1000. We have to find the sum of all natural number. Sum of all natural number lying between 100 and 1000. Lying between 100 and 1000. Okay, 100 and 1000. Natural number. Okay, 100. 101, 102. Okay, there is one condition also, which is multiple of 5. Yeah. So the condition is this. Now 100,000, in between 100 and 1000, and which is multiple of 5. So first would be between, then you don't need to consider 100. So the next number which is multiple of 5 is 105. Okay, 110, again 115. Okay, now last term, it is 1000 is also multiple of 5. So but we are not going to consider it, because we have to find the number between 100 and 1000. So I think 995 would be the, all right. Yeah. Now sum of all natural numbers. So you need to find the sum of all natural number. Before finding natural number, you need to find how many numbers are there between. That means not between. How many terms are there? So you need to find n equal to what? So how would you find it? You have last term, yes, the l equal to a plus n minus 1 into d. What is your l? 995. A is 105 plus n minus 1. What is n minus 1? Need to find this. D is, how you find the common difference? Always you get 5. Yeah. So 995 minus 105 equal to n minus 1 times 5. So it is 0, 9, 8, 90, yeah, upon 5 equal to n minus 1. So what would it be? 5 ones are 5, 5 nines are 45, and 5 8s are 40. Is it right or not? 5 8s are 40, 0. Okay. Five ones are 5. Wrong, sorry. 5 7 35, and 5 8 are 40. 35. Okay. Okay. All right. So 178 plus 1 equal to n. The answer is 179. N equal to 179. So now we have to find what? We have 179 as n. So we can find out as n equal to, what is the formula? N by 2 a plus l. Yeah. So 179 equal to, that means you have to find, this is sum of first 179 terms. Okay. So n by 2, what is n? 179 upon 2. What is a? Is 105. What is l? Is 995. 179. Okay. So 550. 0 1000. All right. Sorry, it is not 1000. 1100, I think. Yeah. 995. So here 11 nines are 99. Okay, 9, 11 7 77, 77 plus 9, it is 86, 6, and 11 1 is 11 plus 8, 19 00. This is the answer. Okay, check it. Okay, 11 7 77, 11 9s are 99. Okay, 9, 11 7 77, 77 plus 9, 86. All right, it is okay. 11 1 is 11, 11 plus. So recalculate it if you have any problem. Important results related to this AP. First result, important result, you need to find that. Important result. Okay, the first result, what is this? This is Tn. This is equal to Sn minus Sn minus 1. What is this? Well, n should be greater than or equal to 2, I think. Yeah. You have to start it from 2. So, okay. Tn is the first nth term. What is Sn? Is the sum of first n terms. What is Sn minus 1? Sum of first n minus 1 terms. So here we are. Okay. Suppose we have sum of n terms given. That means the relation is given Sn equal to n by 2 n square minus 1, like this. Okay. And if you want to find the nth term, how would you find it? So you can use this formula here. This formula, nth term equal to Sn minus 1, where what would be the Sn minus 1 if you want to find using this formula? Okay. So at the place of n, you would place what? N minus 1 upon 2, n minus 1 whole square minus 1. So if you have Sn given, okay, Sn, that means sum of n term from first n terms is given, then you can also find Sn minus 1, that means sum of first n minus 1 terms. And if you, when you put this and this in equation, this equation, you'll get the nth term. So this is the first result. And if the sum of n terms of any sequence is quadratic expression, if the sum of n terms, like if you're finding here sum of n terms, okay, a1, a2, to find the sum, okay, a4, okay, and if you're finding it, the sum is in quadratic equation, okay, like how in n, like an square plus bn plus c, okay, where n is the variable here and abc are constants. So you can say that this a1, a2, a3, a4 up to an is a sequence. It would be in AP, okay, it would be in AP, it is in AP, okay. If you find the sum of sequence in a quadratic equation, then it would be in AP, okay. Now should we do some question here? Okay, we have, if ABC are in AP, then okay, if A, B, C are in AP, so what is the meaning of this? Okay, you have to find what? First, right, let me write the question here first. Then you have to find what is B plus C, C plus A, and A plus B, okay? What is this? You have to check whether it is in AP or not. What? Whether it is in AP or not. In AP or not. Okay, so we are sure about this. Okay, we are going to solve. We are sure about this ABC in AP. So what would be? It is equal to B minus A. The common difference would be same here. We know only about this. So B minus A would be equal to C minus B. So B minus B and plus B equal to C and minus C plus A here, like 2B equal to C plus A. Okay, the common difference D is same. Okay, here you know. That means the common difference you got from subtracting B and A is equal to the common difference you formed by subtracting B and C and B. Okay, so in this case B equal to C plus A by 2. You only know this. If you want to get the idea of this, so what would you do? Whether it is in AP or not, so you have to find the difference, and we have to equate this. Like check C plus A, D equal to C plus A minus what? B plus C. Okay, so it would be C plus A minus B plus C. So here, sorry, minus C. So C cancels. You get A minus B here. Here you can find also D by subtracting A plus B and C plus A. That means the term with the previous term, A plus B minus C plus A, what would you get? Minus C minus A. You would get here B minus C. Okay, so is this equal? I don't think so. It is equal. So what do you have to put? Do you want to create this? What are they in AP or not? Whether they are in AP or not, how would you? A minus B, here we are getting A, B minus C. So equate this. Okay, if they are in AP, if they are in AP, then they will satisfy. Then if they are in AP, if they are, suppose they are in AP. Suppose, okay, they are in AP. Then then both D will be equal like this. Okay, then D equal to D means A minus B would be equal to B minus C in this case. So here A A minus A plus C equal to 2B, and here you see what? A plus C. Here you have A plus C, you can use here. Okay. Oh, no, you can also use, do not solve this. We have B minus A equal to C minus B at the place of B minus C. So we can write A minus B. Also we can if I take common, minus common here and here also minus common, then it would be equal to A minus B would be equal to B minus C. So here we can compare. So in this case both D are equal since since A minus B equal to B minus C here. So when you apply this, okay, you'd get what? The common difference D1 and D2 are equal. So in this case we can see that this sequence, okay, this sequence are in AP. All right. Next question is, if A1, A2, A3 up to AN are in AP, if A1, A2, AN are in AP, so then value of A1 square minus A2 square plus A3 square minus A4 square plus A2n minus 1 square minus A2n square is equal to, well, you need to solve this. There are 4 options, so I want to write the options for you if you want to solve this. 2n minus 1, A1 square minus A2n square, okay. Second option is n upon n plus 1, sorry, 2n plus 1, A1 square minus A2n square. Third option is, you can write here, n upon 2n minus 1, okay, A1 square plus A2n square. And fourth, none of these. What would you do? So pause this video, so try to solve. So here we have A1, A2 up to AN are in AP, okay. Solution. So we have the condition A1, A2, they are in AP. So okay, then the common difference will be, so what would be, what do we know about this? The common difference would be the same, okay. A2 minus A1 would be, since how would you approach? Since A1, A2, A3 up to AN are in AP, so what would you write? You would say that, what do we know? A2 minus A1 equal to A3 minus A2 equal to A4 minus A3 equal to AN minus 1, sorry, AN minus 1. Yes, we know about this. D, the common difference is always same. What more you know about? AN equal to A plus N minus 1 into D, and sum, we know also about the sum. So what is sum? Is Sn equal to, so first n terms, n by 2, 2a plus n minus 1 into D, 2a plus n minus 1 into D, and what more? Sn equal to also n by 2 a plus n. These are the things we know about the AP this time, and we are going to use this in the second one. What is this? This is, okay. So these are the things we know about AP. Now we are focusing on this, okay. So we have the options. We are moving, okay. Solve this, okay. How do you? So you can do A1 square minus A2 square, A1 minus A2, A1 plus A2, okay. Plus we can also apply the property A square minus B square, A3 minus A4, A3 plus A4, okay. What about this? We can also apply here, A2n minus 1 plus A2n minus 1 minus A2n, like this, okay. All right. So what is this? Is A1 minus A2. A1 minus A2 is A2 minus A1 is D. So A1 minus A2 would be minus D. Can we use? Yes, minus D. So use it. So here we use minus D, okay. Minus D, A1 plus A2 a3 minus a4, where is this? a3 minus a4, okay, a3 minus a4 minus a3 is d, so what would be a3 minus a4? It would be minus d, so here you can use minus d like this, okay, a3 plus a4. Similarly, we have also this value would be minus d, the common difference, you know, and you'll end up with a to n like this, okay. Okay, here we are. So take out minus common, yeah, minus d common, not minus only. You'll get a1 plus a2 plus a3 plus a4 plus up to a to n. Oh, in that question I have applied wrong formula because it has 2n terms. How many terms? Oh, also sorry, a1, a2, a3 up to a2n are in AP, okay. They are not sum of first n terms, they have 2n terms, okay. So if you apply the formula here, the sum of not n terms, you know the formula, but at the place of n you need to write what? 2n. The formula would be like this also, n by 2, that means 2a, what is a? a1, okay. What is d? Suppose d is d only, a1 plus d n minus n, what is n? 2a plus n minus 1 into d. Sorry, what is don't Sn is a, write the formula first. Sn is equal to n by 2 a plus l, okay, alright. So we need to find S2n because it contains 2n terms, not n terms, so we are going to apply here 2n upon n, sorry, 2n upon 2 here. At the place of n you are just moving here what? 2n. And a plus l, what is a? Is a1, what is l? L is a to n, okay. We will use this in this because we know we got the expression here a1 plus a2 plus a3 up to a to n. So we are going to use now minus d, what is this? 2n upon 2. When you solve this, you'll get here n a1 plus a to n, okay. But what were the options? In the options, when you see, we don't have minus d and all, so we have to remove this d, okay. How would you remove this? We have a formula, what? an, last term, okay. What is this? Tn is the last term, the nth term, the last term, don't use tn, okay. Last term l equal to, so the formula is a plus n minus 1 into d. a1 plus n minus 1 is 2n, at the place of n it is 2n minus 1 into d, alright. So I have used this formula, okay. So at the place of n you have 2n, at the place of n we have 2m, that's why we are what, putting 2n instead of n here. So can you find here d? Yes, we can. a1 2n minus 1 into d, so how would you find it? Okay, a to n minus a1 equal to 2n minus 1 into d, so d would be a to n minus a1 upon 2n minus 1, alright. This is the option you would use here. So I am going to use at the place of d what? A to n, it is negative, okay. A to n minus a1 upon 2n minus 1 into n is there, okay. a1 plus a2n. So can we, yeah, we can shift here this minus inside, so we would get here minus 2n plus, okay. So you have a plus b, a minus b and a plus b, okay. So you can apply the formula here and you'd get here a square minus b square, that means a 2n a square, a1 square minus a2n square, okay, and n upon 2an minus 1. Is there any option here? We have n upon 2n minus 1 a1 square. Yes, the first option here. First option is this. So we'll solve this question like this. Okay, so let's move to another topic, the arithmetic mean. So arithmetic mean, suppose we have a, b, okay, arithmetic mean of two numbers first we are going to. So suppose a, b are two numbers, and if you want to find out the arithmetic mean, so it would be, or you can say if a is the arithmetic mean of a and b, so here small a, capital A and small b should be in arithmetic progression. That means a minus a equal to b minus a. In arithmetic progression you always get the same common difference, okay. So when you solve this, you will get here 2a equal to b plus a equal to b plus a, that means a plus a, b upon 2. This is what? This is the arithmetic progression of two numbers. Either you can place many numbers, many arithmetic many numbers in between. Yeah, arithmetic progression, what arithmetic mean of two numbers is this. Or if you find the arithmetic mean of n natural number or n numbers, so here we have a1 plus a2 plus a3 up to an upon n is arithmetic mean of n numbers, okay. And one more thing, is there or not? You can introduce many. Okay, that's all about arithmetic mean. So what have you studied about? If you want to find arithmetic mean of two numbers, okay, so you have to introduce capital A in between a and b, because you are going to find the arithmetic mean. So in this case, small a, capital A and small b should be in arithmetic progression, and if I applied here, so this is the condition, you got a equal to a plus b by 2. See, we would use this and would solve one question. If a and b, if the arithmetic mean of a and b is, if arithmetic mean of, okay, a and b is, okay, this is the arithmetic mean, is what is this, a raised to power n plus b raised to power n upon a raised to power n minus 1 plus b raised to power n minus 1, then the value of n, you need to find the value of n. How would you approach this question? Okay, we know about arithmetic mean, the arithmetic mean of a and b. We know what do we know? Arithmetic mean is a plus b upon 2, but it is given what? This. So we can okay, here a is also given a raised to power n, b upon n, a raised to power n minus 1 plus b raised to power n minus 1. So what can we do? We can equate it. So when you equate both a plus b by 2, a raised to power n plus b raised to power n, a raised to power n minus 1 plus b raised to power n minus 1, cross multiply, okay. What can we do? We have no idea, but we are approaching. So b minus equal to 2 a raised to power n plus b raised to power n. Now what would you do? Multiply a raised to power n minus 1 here, so you would get here a raised to power n, a b n minus 1 plus b into a n minus 1 plus b into b, it would be b raised to power n equal to 2 a raised to power n plus 2b raised to power n, like this. Okay, transpose the like terms, we have this, so move it here and move. Okay, so when you move it, a, you'll get here a b raised to power n minus 1 plus b a n minus 1 equal to, subtract 2a raised to power n minus a raised to power n, a raised to power n, 2b raised to power n minus b raised to power a, b raised to power n. What can you do here? You can do with this upon b, yeah, upon a. Yes, can we do this? Yes. What now? Like terms? Yes, we have like terms. So a raised to power n and b raised to power n. So we can simplify it. How can we do here? Yes, we can do a b raised to power n upon b minus b raised to power n equal to a raised to power n minus b a raised to power n upon a. Alright, take a raised to power n common here from, so you get 1 minus b upon a, like this. When you take common from here b raised to power n, you would get here a upon b minus 1. Alright, is it right or not? Yes, it is. So you get a minus b upon b, and here you'd get, is it right or not? I have to check it. Upon b, a b raised to power n upon b, okay, sorry, minus b raised to power n here, and okay, we are moving this here, a raised to power n, a minus b, all right, upon a. So here you got a minus b also. So what do you see here? So b raised to power n, what would you do? Okay, b raised to power n, a raised to power n equal to, transpose it. So a minus b would be cancelled out. You would end up with, okay, what would you get? So transpose it first. A minus b upon a into b upon a minus b. Okay, cancel out b upon a. So you can say that b upon a raised to power n equal to b upon a. Yeah. Oh yeah, we have. So if the bases are same, the powers can be equated. So in this way we can find it n equal to 1. Yeah, it is right. I hope you have understood all the questions. We have any more question. So we'll do many questions here. Thank you very much for watching this video. Thank you very much.